On the eastern edge of Los Angeles County, there is a 500-foot mountain of garbage, 700 acres at the base, the height of a 50-story building at the top. For nearly 6 decades, it received roughly 12,000 tons of household waste every single day. By the time it finally closed in October 2013, it had absorbed somewhere in the range of 130 million tons of trash, making it, by every available measure, the largest active landfill that has ever existed in the United States. Its name is the Puente Hills Landfill. For most of its operational life, the area around Puente Hills was, in epidemiological terms, exactly what you would expect. Rat density in the surrounding neighborhoods ran several times higher than the regional average. Feral cat colonies, drawn by the lights and the food waste and the rats themselves, swelled into the thousands. Los Angeles County agencies spent tens of millions of dollars over the decades on rodent control, pesticide programs, and public health responses to fleas, leptospirosis, and hantavirus. Fumigation campaigns, professional trappers, poison bait stations distributed across a radius of several miles. Almost none of it worked. Anyone who lived in Hacienda Heights or Whittier or City of Industry through the early 2000s will tell you the same thing. The landfill was rats, and the rats were the landfill. That was just how it was going to be. A permanent feature of life on the eastern edge of the basin, as fixed and as accepted as the traffic on the 60 freeway. And then, somewhere in the last decade, something started to change. Rat populations along the eastern edge of Puente Hills began to drop. Not slightly, substantially. Independent studies from urban ecology labs documenting trash can rat density and live trap captures across the Los Angeles basin began recording declines of 30 to 60% in zones near the landfill. Feral cats, once the most visible nocturnal animals in the parking lots and roadsides around the site, began to disappear. Night vision camera surveys that a decade earlier would have captured 4 to 9 cats per night were now capturing 0. In the same areas where the rats and cats were vanishing, a different group of species began to come back. Ground nesting birds, California quail, native sparrows, species that had not been recorded breeding in the urban canyons around Puente Hills for 15 years, sometimes 20. The California gnatcatcher, a federally threatened bird that had largely vanished from the area, was documented breeding in the post-coyote zones for the first time in a generation. The Los Angeles County Department of Public Health did not do this. The city of Whittier did not do this. The sanitation districts of Los Angeles County did not do this. No municipal agency planned it, funded it, or even noticed it was happening for several years. It was done almost entirely by an animal the United States government spent the better part of the 20th century, and well over $1 billion in today's money, trying to kill. The American coyote, Canis latrans, is not an animal that arrived in cities recently. Coyotes have been living in North America for somewhere between 1 and 2 million years. Longer than the bison, longer than the elk, much longer than human beings. They evolved on this continent alongside wolves, mountain lions, and grizzlies as a mid-sized canine predator perfectly adapted to the open grasslands and broken country of the American West. For most of their evolutionary history, they were one species among many in a complete predator guild, held in place by larger animals above them in the food chain. What changed for the coyote was us. Beginning in the 19th century, as European settlers expanded across the West and brought livestock with them, coyotes, which would occasionally take a lamb or a chicken, became early targets of organized predator control. The campaigns began informally on individual ranches and grew into something the federal government eventually took over and systematized. By the 1920s, the Federal Bureau of Biological Survey had essentially completed the extermination of gray wolves across the lower 48 states. Wolves are large, slow-breeding, deeply social animals whose family structure depends on the alpha pair. Kill enough alpha pairs and wolf populations collapse. Within roughly 50 years, the gray wolf was functionally extinct south of the Canadian border. With the wolves gone, the federal government turned its attention to the coyote. And what followed is one of the most genuinely sobering chapters in the history of American wildlife management. In 1931, Congress passed the Animal Damage Control Act, formally expanding federal predator eradication programs. In 1934, the U.S. Department of Agriculture stated in its own annual yearbook that the goal was, and these are the actual words on the page, total extermination of the coyote in the United States. A federal laboratory was created called, with extraordinary candor, the Eradication Methods Laboratory. Its purpose was to develop poisons, strychnine, thallium sulfate, compound 1-thiazide, sodium fluoroacetate, one of the most toxic substances ever deployed in American wildlife management. The M44 cyanide spring trap, known informally as the coyote getter, was developed after World War II, partly using leftover chemical warfare stocks that needed to be repurposed. Between 1947 and 1956 alone, just 9 years, approximately 6.5 million coyotes were killed in the American West. The same campaign from 1937 to 1983 also killed 26,000 bears, 500,000 bobcats, 50,000 red wolves, and 1,600 of the last remaining gray wolves. By the middle of the 20th century, almost every major predator in the western United States had been eliminated from most of its range, except the coyote. The coyote did not go away. Not only did it not go away, it expanded. By the year 2000, coyotes had colonized every single state in the lower 48 plus Alaska. They had moved east. They had moved into the suburbs. They had moved into the cities. By the time the federal eradication budget had been pouring money into killing them for 7 consecutive decades, there were more coyotes in more places than had ever existed before. For most of the 20th century, biologists could not fully explain why. The answer, when it finally emerged from decades of field research, is something genuinely remarkable, and it is the part of this story that most people have never heard. Coyotes have embedded in their reproductive biology and their social behavior 2 specific traits that make them essentially unkillable as a species. The first is called compensatory reproduction. In a stable, undisturbed coyote population, only the dominant alpha pair in each pack breeds. Subordinate females in the group are suppressed hormonally by the alpha female's pheromones. They do not go into estrus. They do not produce pups. The pack stays small. The population is self-regulating. The territory produces roughly as many coyotes as the available food can support, and not significantly more. But when humans intervene, when traps, poisons, or hunting kill members of the pack, the suppression breaks. Surviving subordinate females come into estrus. They breed, and litter sizes increase. In a pressured population, the average litter goes from 4 or 5 pups up to 6, 8, sometimes 10. With fewer competing adults around to take resources, more of those pups survive to breeding age. Peer-reviewed research from Wildlife Services researcher Eric Gies, working in southeastern Colorado, demonstrated that even after removing 60 to 70% of the coyotes in an area, population density rebounds to its pre-removal level within roughly 8 months, sometimes higher than before the removal began. The harder you push, the more coyotes you create. The second mechanism is called fission-fusion social structure. When a coyote pack is harassed, it does not collapse like a wolf pack. It scatters. The members go from being a coordinated family group to becoming a network of individuals in pairs roaming across a wider landscape. Each of those individuals carries the genetic and behavioral programming to start a new pack somewhere else. They move into territory that previously had no coyotes. They establish footholds. They breed. So the harder humans push the coyote, the wider it spreads across the landscape. The United States spent the better part of a century and billions of dollars trying to wipe this animal off the continent. The campaign accomplished the exact opposite. It made the coyote more widespread, more genetically flexible, and more behaviorally adapted to human-dominated landscapes than it had ever been at any previous point in its history. The eradication program did not eliminate the coyote. It accidentally selected for and distributed across the entire continent the coyote that could survive in cities. Which brings us back to Los Angeles. By the early 2000s, coyotes had been established in the Los Angeles basin for decades. They lived in the canyons of the Santa Monica Mountains. They moved at night through the storm drains and the concrete bed of the Los Angeles River. They crossed freeways through culverts. They dispersed through Griffith Park, Elysian Park, and Baldwin Hills, filtering slowly eastward through the basin along creek corridors and canyon systems. Eventually, they made their way to the foothills around the Great Mountain of Garbage at Puente Hills. In 2020, a research team led by Justin Brown of the National Park Service's Santa Monica Mountains National Recreation Area, working with researchers at California State University Northridge, published a paper in the journal PLOS One analyzing the diets of urban coyotes across Los Angeles. They used scat analysis, identifying the contents of coyote droppings under a microscope, and stable isotope analysis of coyote whisker tissue, which can reveal what an animal has been eating across weeks or months in the past. The study worked with over 150 citizen science volunteers. The data set is one of the most comprehensive ever assembled on urban predator diet in North America. What they found is, in context, remarkable. Urban Los Angeles, coyotes get approximately 65% of their diet from human-related sources. That includes ornamental fruits. 26% of urban scat contained figs from non-native trees, dates from palms, pyracantha berries, items that exist in the city only because humans planted them. It includes garbage, and it includes domestic cats. 20% of urban coyote scat contain cat remains. Pause on that number. 1 in 5 coyote droppings on average across the Los Angeles basin contain the physical remains of cats. The researchers strongly suspect the majority of those cats are feral rather than pet. Around Puente Hills specifically, where feral cat colonies had built up over decades alongside the landfill. The proportion is almost certainly higher. The coyotes that established themselves around Puente Hills were eating the rats directly, and they were eating the feral cats. And the feral cats themselves, which had previously been one of the largest direct predators operating on the local rat population, were being suppressed in the process. But here's the part of the story that genuinely surprised researchers when they first examined it closely. Most of the rat decline is not actually caused by coyotes eating rats. Most of it is caused by something more interesting and more important. Something biologists call the landscape of fear. When a predator establishes itself in an environment, it does not only kill some fraction of the prey population, it changes the behavior of the entire prey population. Prey species become more cautious in ways that have measurable physiological consequences. They shift their feeding times to windows when they believe the predator is least active. They reduce the distance they will travel from cover. They abandon nesting sites in exposed locations. They stop traveling in large groups because large groups attract attention. And this is the mechanism that drives the population level effect. They experience chronic physiological stress. Studies on rats and other small mammals have demonstrated that the simple presence of predator scent without any direct predation occurring can elevate cortisol levels by 200 to 300%. Chronically elevated cortisol in rats reduces fertility. It reduces successful pregnancies, it reduces birth weights, it increases mortality among newborn pups in the first 10 days of life. The predator does not need to catch the prey to suppress the population, it only needs to be present. So what happened around Puente Hills worked like this. The coyotes moved in. The rats encountered coyote urine and scat. Pheromone signals their evolutionary biology recognized immediately as a lethal threat, even though most of these urban rats had never encountered a coyote before in their lives. They began behaving differently. They shortened their foraging windows. They stopped moving in groups. They abandoned the most exposed sections of the landfill perimeter. The females began producing fewer successful pregnancies. The pups that were born were smaller and more likely to die in the first weeks of life. Simultaneously, the feral cats, extraordinarily sensitive to coyote pheromones, began abandoning the area. Those that stayed got eaten. Within a few years, the cumulative effect of behavioral suppression, direct predation on cats, and reduced cat pressure on rats produced something that decades of municipal pest control had never managed to produce. A sustained, measurable, multi-year decline in both populations. 30 to 60% fewer rats, 80% or more fewer feral cats in specific zones around the landfill. The Los Angeles County Public Health Department did not spend an additional dollar. The coyotes did it entirely for free. And then the third effect kicked in. Rats and feral cats are not only nuisances in the human sense, they are two of the most destructive predators on small native birds anywhere in urban North America. Feral cats alone, according to research from the Smithsonian Migratory Bird Center, kill somewhere between 1 and 4 billion wild birds in the United States every single year. Rats destroy ground nests, eat eggs, and prey on nestlings across species that have no evolutionary defenses against a mammalian predator raiding at ground level. When the cats and rats around Puente Hills began to disappear, the ecological space they had been occupying opened. Ground nesting birds moved back into it, California quail, spotted towhees, wrentits. The California gnatcatcher, federally threatened, largely absent from the area for a generation, documented breeding in the post-coyote zones. What ecologists call a trophic cascade. One predator reestablishes at the top of a food chain and the effects ripple downward through every layer. The mid-level predators, the cats, get controlled. The prey they had been consuming, the birds, get released. The primary prey, the top predator, is suppressing through fear. The rats stop dominating the lower ecological levels. The entire system rebalances around the presence of a single returning species. The most widely known example of a trophic cascade in modern conservation is the return of wolves to Yellowstone, credited with changing elk behavior and allowing riparian vegetation to recover. That story carries some scientific debate around its precise mechanisms, but the underlying principle is documented and real. What happened in the urban canyons around Puente Hills is, in measurable terms, a smaller-scale urban version of the same dynamic, playing out across suburban parking lots and canyon trails rather than mountain meadows, but driven by the same ecological logic. None of this is an argument that coyotes present no cost to the communities they move through. They do sometimes kill pet cats and small dogs. They will, in extremely rare cases, make contact with humans, according to USDA data. Fewer than 3 serious coyote attacks on humans occur across the entire United States in an average year, a figure that sits vastly below dog attacks, deer vehicle collisions, or bee stings in terms of statistical risk to human health and safety. But attacks that do happen tend to be widely publicized in ways that dominate local political conversations about wildlife policy out of all proportion to their actual frequency. There are communities where residents have voted in recent years to bring back lethal coyote control after a series of pet losses. And the science on what that produces is consistently and depressingly clear. Killing coyotes does not reduce coyote populations in any sustained way. It triggers compensatory reproduction. It scatters survivors across a wider landscape. It accelerates the spread of the remaining animals into territories they had not yet reached. The human-coyote conflict, at its root, is not an ecological problem that population control can solve. It is a cultural problem about what level of wildlife presence urban communities are willing to accept. The science on what the coyote contributes to a city's ecological health is unambiguous. The benefit, measured in rat suppression, feral cat reduction, and native bird recovery, is real and documented and sustained over years without ongoing cost. The cost, measured in occasional pet losses and exceedingly rare human encounters, is also real but is dramatically smaller than public perception suggests. The gap between the statistical reality and the perceived risk is where most of the political difficulty lives. In 2021, a single small coyote pack operating in a series of parks in a residential neighborhood in Toronto was lost, most of the adults killed in a series of road accidents within a short period. Nobody planned it. It was simply the accidental end of one specific small population. Within 3 to 4 weeks, the rats came back. Cleanup crews started receiving calls about overturned trash bins again. Feral cats reappeared in the same parks. Over the following 3 months, surveys of breeding birds in the area documented a sharp decline in the ground nesting species that had been recovering for years. No computer model was required to interpret the result. Reality answered the question on its own. When you look at Puente Hills today, this enormous, capped, slowly revegetating mountain of garbage on the eastern edge of one of the largest cities in the world, you're not only looking at a closed landfill, you're looking at one of the most successful unintentional rewilding projects in modern American urban history. A place where, over the course of roughly a decade, one of the most hunted animals on the continent quietly walked back into the landscape, established territories, began raising pups, and started doing the rat and cat control work that human agencies, with all of their money, all of their technology, and all of their public health infrastructure, were never able to do at scale. We spent the better part of a century and well over $1 billion trying to eradicate the coyote from the American landscape. We failed completely. And in failing, we accidentally created and distributed across every corner of the country the very population that is now, quietly and without anyone's permission, repairing some of the ecological damage the city of Los Angeles has done to itself. The lesson embedded in all of this is one we tend to resist. We assume the natural world is something that happens out in the wilderness, in the national parks, in the protected reserves far from where people live. Cities in this view are concrete machines that nature can only briefly visit before being pushed back out. The coyote of Puente Hills says something different. The natural world is here too. It operates in the storm drains, in the canyon systems, in the spaces behind the strip malls and along the concrete beds of channelized rivers. And the species we have failed most spectacularly to control are sometimes, when finally given the space to operate, the ones doing the most consequential ecological work. The rats are vanishing. The cats are vanishing. The birds, for the first time in a generation, are coming back. That is, by any honest accounting, the kind of comeback story we are not usually willing to tell.